Module 1.5, Scientific Notation. It will be very helpful to understand how to use scientific notation, as some of the numbers we will be using will either be very large or very small. Scientific notation will make dealing with these numbers easier. It will make calculations easier, and it will reduce or eliminate decimal point mistakes. Basic scientific notation takes the form of a number, the coefficient, multiplied by a power of 10. Some examples are 3,000 equals 3 times 10 to the third. 0.0000452 equals 4.52 times 10 to the minus fifth. Here's a guide on how to use the power of 10. If the power of 10, or the exponent, is a positive number, add that number of zeros after the decimal point. Examples: 8 times 10 to the fourth equals 80,000. There's 4 zeros after the 8. 1.25 times 10 to the seventh. You need to add 7 zeros after the decimal point. Since there are 2 numbers after the decimal point, we only have to add 5 more zeros, so we get 12,500,000. Going the other way, take the number of zeros to the left of the decimal point and make that the exponent. 410,000 equals 41 times 10 to the fourth. There are 4 zeros to the right of 41. If the exponent is negative, the whole number goes that number of places to the right of the decimal point. Examples: 5 times 10 to the negative third equals 0.005. The 5 is 3 decimal places to the right. 7.32 times 10 to the minus 6 equals 0.00000732. The 7 is 6 decimal places to the right of the decimal point. 7 is the whole number. 0.32 is a fraction. 89 times 10 to the minus fourth equals 0.0089. 89 goes 4 decimal places to the right. Going the other way, the number of decimal places to the right gives you the negative exponent. Examples: 0.00000002 equals 2 times 10 to the minus eighth. The 2 is 8 decimal places to the right. 0.00045 equals 4.5 times 10 to the minus fourth, or 45 times 10 to the minus fifth. For the first answer, the 4 is 4 decimal places to the right. For the second answer, 45 is 5 decimal places to the right. Both numbers are correct and represent the same value. Please note, 10 to the 0 equals 1. 10 to the 1 equals 10. Scientific notation math: multiplying, dividing, and exponentiation. When multiplying powers of 10, add the exponents. 10 to the fifth times 10 to the second equals 10 to the seventh. 10 to the minus third times 10 to the minus second equals 10 to the minus fifth. 10 to the minus fourth times 10 to the fifth equals 10 to the 1 equals 10. 3 times 10 to the sixth times 2 times 10 to the fourth equals 6 times 10 to the 10th. We multiply the 3 times the 2 to get 6, and we add the exponents of 6 and 4 to get 10 to the 10th. When dividing by powers of 10, move the 10 in the bottom to the top and flip the sign. For example, 4 divided by 10 to the third equals 4 times 10 to the minus third. The 10 in the bottom moves up to the top. The positive 3 exponent becomes a minus 3 exponent. Here's a more complicated example. 14 times 10 to the minus second divided by 7 times 10 to the minus sixth. First, we move the 10 in the bottom to the top and flip the minus 6 to positive 6 to give us 14 times 10 to the minus second times 10 to the sixth over 7. Then we add the exponents, minus 2 plus 6, to get 10 to the fourth. Finally, we divide 14 by 7 to get 2 times 10 to the fourth. When raising a power of 10 to another power, multiply the exponents. 10 to the fifth squared equals 10 to the 10th. 5 times 2 equals 10. By the way, to make an exponent in Microsoft Word, use the superscript button at the top left of the window. To review, scientific notation is a number multiplied by a power of 10. We use it to make very large or very small numbers easier to deal with and to reduce and eliminate decimal point errors. For positive exponents, add that number of zeros after the decimal point. For negative exponents, the whole number goes that number of places to the right of the decimal point. When multiplying powers of 10, add the exponents. When dividing by powers of 10, move the 10 in the bottom to the top and flip the sign. When raising a power of 10 to another power, multiply the exponents.